This call is now being recorded.
Welcome back, all of you. So today we are going to discuss about the philosophies of reinforced cement concrete design, and in that today we are going to discuss about the ultimate load method and limit state method. In last lecture, we have discussed about the working stress method, that how this working stress method was evolved and what are the points which are the main key points of that working stress method that we have discussed in last lecture. Now today we'll just discuss on the ultimate load method, that is ULM, or this ultimate load method is sometimes also referred as load factor method. So this ultimate load method we are going to discuss, and after that we are going to discuss about the limit state method. So let us start with this session. So as already I have told you in last lecture that the ultimate load method is a modified version, or you can say that not exactly the modified version, but after seeing the limitations of working stress method, some points which were considered or which were assumed in working stress method are not as per the actual conditions, and that's why normally the whatever sections that we are getting in working stress method are uneconomical. That is, the dimensions of sections we are getting is much more, and again the whatever load that we have considered in working stress method, that is the working load and the stresses which are going to develop at the working load, those only considered in the design. So it will not provide us a very good safety in case of some uh, incidences like that, due to maybe change in the use or due to any other reason. If the loads are increased beyond that permissible values or the considered values, then there may be possibility of failure of structure, and that failure may be sudden. So which will be a disastrous condition. So those are the limitations of working stress method, and that's why only that by considering all these points, all these factors, some modifications have been done, and a new method of design was developed. That method is called as the ultimate load method. So this ultimate load method is adopted or developed in 1950s, and this is also called as ultimate load method, or it is also termed as a load factor method also. So as per WSM, in a working stress method, what we have seen that whatever relationship between stress and strain, they have assumed as a linear one. That stress-strain relationship assumed in working stress method is a linear one. Means linear means they are assuming that if you plot a plot or graph of load against deflection, or we can say it as a stress versus strain. So as per WSM, this relationship is a linear one. The stress will directly proportional to strain. As you increase stress, the strain is also going to increase. But that is not the actual condition. Okay? That is not the actual condition. Means what happened that up to this point, that is in the to 1950s, that it is assumed that the load is going to increase, or that whatever metal, reinforced cement concrete, the concrete and the steel, what we are going to, they can take the load and it deforms as you increase the load. That is the assumption. It is directly proportional, or you can say that it is a linear relationship they have assumed, but that is not the actual condition. That when you perform actual experimentation on the steel as well as actual experimentation on the concrete also, then you will find that this relationship is not linear one. Okay. Normally what happens that up to the certain limit, we call that limit as the elastic limit. So up to that elastic limit, this stress strain varies linearly. But then it will not, that whatever relationship is not a linear one. Then afterwards we will found that this kind of nature of graph you will obtain. Okay, so it means that suppose this particular graph is for the milestone. So if you plot that graph, it means that as you increase the load, up to the some point, that as you increase load, the elongation of steel is also going to take place in the same rate. So this relationship is a linear one. Stress is directly proportional to strain, but up to what limit? That up to the elastic limits only. Elastic limit means every body means is having some elastic properties or elastic limits. So as per the Hooke's law, Hooke states that up to the elastic limit only, that whatever stress carried by the body and the strain developed in the body remains or grows constantly, or variation will be the constant one. Okay, and that particular law is called as Hooke's law. So Hooke's law states that stress is directly proportional to strain up to the elastic limit. And based upon that, we have developed some equations, and all those equations are known to you. Okay, and that at what point this stress you will get this maximum point. This first peak point is called as a yield stress. Okay, but at this point, I think it is visible to all of you. At this particular point where the inclination of this curve starts, here that one process or one term that you might have heard about, that strain hardening will take place. Okay, and due to the strain hardening, you will find that as you increase the load, the stress is not going to increase, but the elongation is going to increase. Okay, means at this point, what happens? That as suppose if you are going to take a rod you have taken, and you are going to apply the tensile force on this bar like this. Okay, so sorry. So as you apply the tensile force on this bar, okay, as you apply the tensile force on this bar, what happens? That up to elastic limit, you will find that there is no change in the direction, change in the dimension or the diameter of the bar. Okay, you have performed this experiment in the strength of materials laboratory. But after this point, what happens? At somewhere, at some location, the reduction in diameter of this bar will take place. Okay. The reduction of diameter of bar will take place, and as you increase the load continuously, you will find that after some point, some time, that there is a reduction in the stress. And why this reduction is happening? Because the cross-sectional area at this particular junction is going to reduce. And as this cross-sectional area is reducing, the stress value is increasing, and after some times that again that this steel is going to carry the load, and after this reaching to the second yield point, then you will find that sudden rupture of this bar will take place. Okay, so this process from this point to this point, this total process is called as strain hardening, and this process is called as the neck formation. Okay. So this necking or neck formation process you have studied in the strength of materials laboratory. So this is the actual behavior of steel. If you plot the stress versus strain graph for concrete also, then you found that for the plain cement concrete, that normally we are casting the beam and we are applying the point load on that concrete. So you found that as you increase the loads, some minor elongation is going to take place, and that relationship is linear. But after some times, what happens? Some deformation goes on increasing, but the load is not carried by that concrete, and sudden rupture will take place. So this is the general relationship, stress-strain relationship for the concrete. Okay, these values may increase as per the grade of concrete. That for M15 grade, you might see that this will be the curve. M20, this may be the curve. For M25, this may be the curve. Okay, but the nature remains same. And this nature is also non-linear, and this nature is also non-linear. That the stress-strain variation is non-linear one, and we have to consider this factor. Why? Because that as you are going to use reinforced cement concrete, means you are adding concrete and reinforcement, and that you are going to use for the structural members. Okay, so this property, if you don't consider, if you don't consider the actual behavior of metal while designing that particular component of the structure, then when that load is going to exactly affect the structure, there may be sudden failures or sudden collapse of structure is possible. Okay, so by considering the actual behavior of materials, you can utilize those materials in a very good manner. Okay, so that is done or that is considered in ultimate load method, and this new method was developed. Okay, so in ultimate load method, the stress condition at the state of impending collapse of structure is analyzed using non-linear stress-strain curve. Okay, non-linear stress-strain curve. These two curves are called as a non-linear stress-strain curve, and that whatever stresses which are going to develop at the collapse means collapse means what, when the structure or when that metal fails. So at that particular point, or the exact stresses which are going to develop at that particular instance, those can be evaluated by only studying this effect, non-linear relationship of the material. Okay, so that is considered in ultimate load method. So here you can see that these are the for the steel and concrete stress strain curve relationship. That this will discuss in detail again in upcoming lectures. Okay. Some points regarding ultimate load method, as we have discussed in case of working stress method, also in working stress method we have used the factor of safety. Okay, so in the same way here in case of ultimate load method also there is one more factor, design factor, that is called as a load factor. It is also not means exactly it is not termed as a design factor, but we can call it as a load factor, and this load factor is provided only to achieve the safety measure. Safety measures which is not considered in working stress method. Safety of structure or safety of users was not considered. Okay. That whatever stresses which are going to develop, those are considered developed due to the working load only. But actually in practice, that sometimes the loads may exceed beyond these working loads, and most of the times these loads may remain below the working load. So this condition or this effects was not considered in working stress method, and in ULM it is considered. So, and again some importance is given to the safety also. Okay, so for consideration of this safety measure, the uh, design is introduced by an appropriate choice of load factor, and that load factor is defined as the ratio of ultimate load to the working load. Now, what is meaning of this ultimate load and the working load? So, working load already I have told you. So, what is meaning of working load? Working load means
Actual load applied on structure.
okay. So, it is the actual load, and the ultimate load means. Can anyone tell me what do you mean by this ultimate load? Route? Any just guess what will be the ultimate load?
Load applied on the structure up to component will be failed.
Sorry.
All loads applied on structure, example dead load, live loads.
No, that is again working load is same. That working load means it is a combination of dead load and live load. No, no problem. But what will be the ultimate load? Already I have told you that working load is nothing but it is means the self weight is already all the time is acting on that particular structure. Okay, that is dead load. And the load of cursors or load of furniture is called as a live load. So that may varies, but that load we have to consider as a total working load, a combination of dead load plus live load. But ultimate load is something in addition to that.
Wind load and
No. Diploma holders are aware about that. Shivankar, Raghav Sitaram, Saurabh बोला. सौरभ रोकडे. हाँ. Okay, let me tell you. That ultimate load is nothing but it is a load that can be carried, maximum amount of load that can be carried by that particular member. So we can say that it is a load carrying capacity of the member. Ultimate load. Ultimate means it is the maximum load can be carried by the element. Okay, before failure of that element or before failure of that material. So you can calculate that by using this relation, that is ultimate load will be equals to working load into some load factor, or the load factor you can calculate. Load factor will be equals to ultimate load divided by the working load. Now this ultimate load we can calculate just by performing some experiments on the materials. Okay. Can we calculate in that way? Ultimate load carrying capacity of the material can be calculated just by performing the experiments, and the working load that you have to assume. Or you can calculate based upon the codal provisions. So by knowing ultimate load and by knowing the working load, you will be able to get the load factor. Or vice versa, by knowing the working load and by knowing the load factor, you can calculate the ultimate load. Or by knowing the ultimate load and by knowing the load factor, you can calculate the working load also. So anything is possible, just you must know the two values. Okay. So that factor were adopted here in ultimate load method, so that method is also referred as the load factor method. So this method, that ultimate load method, is based upon the ultimate strength of reinforced concrete at ultimate load. Ultimate strength of reinforced concrete at ultimate load means it is nothing but that what will be the strength possessed by the reinforced concrete material or reinforced concrete element whenever it is subjected to the ultimate load. Okay. What are the stresses which are going to develop in that particular reinforced concrete element at the ultimate load? Those stresses were considered in the ultimate load method, and that the ultimate strength can be obtained by enhancing the service load. Enhancing is nothing but that you have to increase the service load or you have to increase the working load just by applying an additional factor here. Okay, so ultimate load will be equals to working load or service load into load factor. Okay, so this will give us a desired margin of safety. Is normally for the design purpose we are going to consider this ultimate load. So this ultimate load is normally more than the actual load. It remains more than the actual load because here it is the actual load, and you are going to calculate the ultimate load just by using this relation WL, that is working load into load factor. Okay, so this is the actual load. You are increasing this actual load by this load factor. So for the design purpose, you are using the load more than actual. So this will provide us some additional safety. It's for the design purpose we are considering the more load, but actually on the structure always the load going to applied will be lower than the actual load. So this will provide us safety. Okay, and that is the additional point which we have considered here in ultimate load method. So this different load factors were assigned for the different loads. Different loads means, again, just right now as I think Vinayak mentioned that dead load, live load, wind load, earthquake load, these are the different loads, and the probabilities of application of this load is again varying. Okay, Dead load will be always there. Live load may varies. Again, wind load may varies and earthquake load may varies. So it is not the condition that always wind is going to act on the structure. Okay, असं होतं कधी की कायम 12 महिने कायम वारं त्या पर्टिक्युलर एरियामध्ये तेवढ्या स्पीडमध्ये वाहतोच. Okay, that wind intensity may varies. Again, seismic activities are not happening every time. It may occur at any one instance. Okay, but that load we have to consider the purpose. So for each kind of this load, you have to consider different load factors. Different load factors were to be considered, and hence this method is referred as a load factor method. Load factors we are calculating as per the conditions for the different loads. And that is the main reason why we are calling this method as the load factor method, and we are calling it as the ultimate strength method only because for the design purpose we are considering the ultimate strength of the material. Are you getting?
Yes, sir.
Okay. Okay, so by using this ultimate load method, we will found that there is a satisfactory strength performance at ultimate load, but it will not provide us the guarantee regarding the serviceability performance at normal service load. Now, what is meaning of the serviceability performance? Can anyone tell me? You can read this point particularly. Is it visible clearly? This last line on your screen. The satisfactory strength performance at ultimate loads does not guarantee satisfactory serviceability performance at normal service load. सांगता येईल का त्याचं मीनिंग काय? Satisfactory strength performance at ultimate load does not guarantee satisfactory serviceability performance at normal service load. काय सांगता येईल? ठीक आहे, यातलं एकच मी उदाहरण सांगतो तुम्हाला, एक जस्ट एक्झाम्पल दॅट द क्वालिटी ऑफ मटेरियल. The satisfactory strength performance. Strength of material depends upon the quality of material that what you are going to use. Okay, you are considering that whatever material that you have already used in the structure, which is having some quality, but again that we have to perform some checks regarding that quality. If you don't perform that check, then there may be that quality of material may be inferior one, and due to that, there may be possibilities of that material will not carry the loads what we have considered for the design, and in that case there may be failure. Okay, so that is the possibilities, and that is again one kind of you can say that the limitations of ultimate load method. Okay, so that also we have to consider, and as a point of consideration, some revisions are to be done in this method, and those are done, and after correction of this kind of points, small minor corrections, we have got the ultimate load method, limit state methods, okay, in which we are considering the different limit states. So we'll discuss about that. So again, some points regarding this method, that this method generally results in more slender sections. Now slender, what is the meaning of slender sections? This is the advantage over WSM. In working stress method, the section sizes what we have received, those sections are of greater size. Okay. Means whatever sections of the beam column sizes what we have obtained in case of working stress method, those are larger, and that's why we said that the section sizes are larger and it is uneconomical. But as here in case of ultimate load method, you are considering the maximum or ultimate load for and ultimate strength of the metal. So that's why we'll be able to reduce the section sizes. Okay. So you will get the economical sections or the smaller sizes for the beams, columns, slabs, etc. And it will provide us an economical design. Okay. But for the satisfactory strength performance at ultimate load does not guarantee satisfactory serviceability performance at normal service load. This point already I have explained right now. And the design sometimes results in excessive deflation. Okay. Okay. This point, what I have discussed in relation to this point, that particularly there may be possibilities of some kind of incidences that due to lack of proper workmanship or due to any other reason, there may be possibilities of some inferior strength or the less strength of metal may be available. So in that case, you will find that the excessive deflections may happen. Excessive deflections means deformation may be more, and which creates the insecurity among the users. So there is no any guidelines regarding in ultimate load method. So this ultimate load method doesn't consider the serviceability criteria like the deflection. That what should be the deflection limit or how much the maximum deflection allowed. That is not considered in ultimate load method. So that is the again one kind of drawback. So because what happens that if suppose we don't consider the excessive deflections and points regarding the crack widths are nothing but suppose if excessive deformation happens, then as we know that as the tensile forces or tensile stresses are increasing in the concrete, that concrete will not carry the tensile stress and the cracks will get formed. And that crack will start from the bottom of that concrete section. Okay, if this is the concrete section, if you apply the load like this, so crack will start from this bottom, soffit. Okay. And this whatever crack size, or normally the crack size is referred as crack width. Okay. So if there are some limitations regarding this crack width. If that crack width is beyond that permissible value, then what happens? That moisture will start penetrating from this, and corrosion of reinforcement will start. Okay, so that is now again considered in ultimate load method. And due to this, what happens? And that whatever sections that we have assumed, those sections will not be able to carry the loads. Okay, owing to the slender sections resulting from the use of high strength reinforcing steel and the concrete. Okay, and there may be possibilities of failures. Okay, so that's why the ultimate load method is also not continuously used. So some modifications were done in this ultimate load method, and a new method was generated or developed, and that new method is called as a limit state method. Okay, so this limit state method we'll discuss right now. Any doubt? If you have any doubt up to this point, then you can ask me.
What is the difference between satisfactory strength and satisfactory serviceability?
Okay, that is what I have already told you. Satisfactory strength means that the strength that can be carried by the structure or that materials satisfactorily to achieve the satisfactory performance. Satisfactory performance म्हणजे काय, फॉर एक्झाम्पल किंवा तुम्ही एक M20 ग्रेडचं मटेरियल वापरलं आहे आणि आपण असं काय अपेक्षा करतो की ते M20 ग्रेडचं मटेरियल आहे म्हणजे त्याची कॉम्प्रेसिव्ह स्ट्रेंथ किंवा कॅरेक्टरिस्टिक स्ट्रेंथ असत 20 न्यूटन पर mm². Okay. So satisfactory performance or satisfactory strength means that whatever concrete that you are going to use, which is having a compressive strength of 20 Newton per mm², that must carry that much amount of load. 20 Newton per mm² stress carry केलाच पाहिजे. That is called as a satisfactory performance. Okay. But sometimes what happens, as it is mentioned, that it does not guarantee the satisfactory serviceability. Now, serviceability means what? So if you that we are going to discuss also in limit states also. So there are certain limit states. That limit state of deflection, that is one check. What happens that here, as I mentioned here, that in case of ultimate load method, we are getting the slender sections. Slender sections means the dimensions of sections what we are getting in ultimate load method is comparatively very smaller than the working stress method. So being a slender sections, what happens that deflections in the member will be more. Okay, and as that deflection is more, so again we cannot use that particular structure satisfactorily. That serviceability performance means how that structure behaves actually during service time. म्हणजे सर्व्हिस टाइम म्हणजे ज्यावेळेला आपण एखादं स्ट्रक्चर वापरत असतो त्यावेळेला त्याच्यात डिफॉर्मेशन किती आहेत, डिफ्लेक्शन किती आहेत, ते जर परमिसिबल व्हॅल्यूज पेक्षा जास्त असतील, म्हणजे समजा तुम्ही एखाद्या स्लॅबवर गेला आहे आणि 5 लोकांची कॅपॅसिटी आहे, ठीक आहे 5 लोक तिथं आहेत आणि एखादा 6वा माणूस आला आणि जर एक्सेसिव्ह डिफ्लेक्शन झालं तर काय होईल? There will be insecurity among those users. So तुम्ही व्यक्तीने काय कराल ते तर बिल्डिंग सोडून पळून जाल. Okay, so that may happens, and that is the limitation that because while designing those structural members in ultimate load method, there is no consideration about this serviceability criteria. Means how that structure is actually behaves, what will be the maximum deflection, or what should be the limited deflections. These kind of factors were not considered. आणि हेच फॅक्टर परत कन्सिडर केलेलं आहे सॉरी ऍडिशन मध्ये आणि त्यालाच आपण म्हणतो लिमिट स्टेट मेथड. सो इन लिमिट स्टेट मेथड वी आर कन्सिडरिंग डिफरंट काइंड ऑफ लिमिट स्टेट्स and one of that limit state is a limit state of deflection, and such kind of different limit states were there, and that's why only we are calling that method as a limit state method. That we'll discuss better. मीन्स तुमची शंका क्लिअर झाली का?
Yes, sir.
अजून काही शंका कोणाला? डाऊट? पांडे, बागडे, मलानी, हुसेन, रंजित, बागल, ओंकार माळी, रामनागने, रिप्लाय द्या.
No,
स्वामी शेळके, पूजा शेळके, विनायक पवार, बागल सीताराम, राहुल चव्हाण, माने,
No, sir.
प्रशांत पवार,
No, sir.
गरड, राजश्री.
Yes, sir.
एनी डाऊट?
No.
रावंदरे, रज्जू,
हाँ सर.
काही शंका आहे का?
नाही सर.
काही शंका? ठीक आहे. Okay, so then we'll move to the next point, and just we'll discuss about the limit state method. What is the meaning of limit state method? That only we'll discuss, and I think that much time we have only. So just we'll discuss an introduction to the limit state method. So आतापर्यंत आपण बघितली की वर्किंग स्ट्रेस मेथड मध्ये काहीतरी ठराविक गोष्टी कन्सिडर केल्या होत्या. That some points were discussed and some points were considered in working stress method. As per the working stress method, some structures were designed and provided, but again there are some limitations that the section sizes are more. The behavior of structure is not safe, or safety factors were not considered. So again, some modifications were done, and load factor method were developed. And again, in that load factor method, there is no consideration of serviceability conditions. So again, those modifications were done in the ultimate load method, and again, the more refined method were provided, and that method is called as the limit state method. Okay, so we'll discuss on this limit state method. So as I told you, that the philosophy of limit state method of design represents a infinite advancement over the traditional design philosophy, means working stress method and ultimate load method. There is some advancement or some modifications or some more refinement of ultimate load method gives us the limit state method. Okay, so as I already discussed about this, unlike working stress method, which is based on the calculations on the service load conditions alone, and unlike ultimate load method, which is based on the calculations on ultimate load conditions alone. म्हणजेच काय वर्किंग स्ट्रेस मेथड मध्ये फक्त आपण सर्व्हिस लोडचा विचार करतो. अल्टिमेट लोड मेथड मध्ये काय झालं की तुम्ही अल्टिमेट लोड बघितला. That the ultimate load and ultimate strength of metal that you have discussed only, and you have designed the structures likewise. Okay, but in limit state method, what we are aiming that a comprehensive and rational solution to the design problem by considering safety at the ultimate loads and serviceability at the working loads. Okay, so that is the highlighting point. That what is this meaning of safety at ultimate load and serviceability at working load. Now, so for that, just again, I'll recall that ultimate load is the maximum load that can be carried or that can be acting on the structure, and the working load is the actual load which is going to act on the structure. So it says that in limit state method, what we are doing that we are considering the points which were not considered in working stress method also and in ultimate load method also. Working stress method discuss about only the service loads or the stresses which are going to develop at service loads. Ultimate load method discuss only about the ultimate loads or ultimate strength of materials. Okay. म्हणजे जेवढं मॅक्सिमम कॅपॅसिटी आहे तेवढं डिस्कस तेवढा लोड कन्सिडर केला तेवढं स्ट्रेंथ कन्सिडर केला आणि डिझाईन केला. ठीक आहे. म्हणजे थोडं काय होईल काय काय केस in that case also you are considering the maximum strength of material and accordingly you are designing the section. So there may be possibilities of sometimes there may be possibilities like load may increase beyond that value also or most of the time load will be smaller than that. So again, there may be possibilities of sections. What we are getting is maybe uneconomical, and that is happening in working stress method. So to avoid these kind of conditions, in limit state method, we have used the concept that safety at ultimate load. That whatever structure that you are going to design, it should remain safe at the ultimate loads or the maximum load that can be carried by that element, and during this it should be serviceable during the working loads. So serviceable means that whenever that particular structure is subjected to working load, at that working load the deformations or deflections produced in that structure should be within the specified limits. It should produce a safe environment or safe kind of what you can say that safety must be felt by the users also. Okay, so that is called as a serviceability. Serviceability means whenever that particular component is actual service, it should behave satisfactorily. Okay. Now for achieving this, what we are doing in limit state method, that our structure should be designed to sustain safely the loads and deformation when it is being used. That is when that is in service, and have adequate durability during its anticipated service life. Because again, one point that as we know that concrete will not remain in the same state for its total lifetime. Am I correct? Concrete will not remain in the same state during its total lifetime. Or is it being to be in same state during the lifetime of the concrete?
It will be changed.
म्हणजे मी आज कॉन्क्रीट कास्ट केलं आणि आज कॉन्क्रीट कास्ट केलेल्या कॉन्क्रीटचे जे काही प्रॉपर्टीज आहेत सेम प्रॉपर्टीज मला 100 वर्षानंतर मिळतील का?
No, sir.
Because there will be environmental effects on that concrete. So disintegration, or you can say that deterioration of concrete may take place. Okay. So we have to consider these total conditions, and that is called as durability. So durability conditions were not considered in working stress method as well as in ultimate load method. So that points you have to consider that how actually that building or component is going to provide services during its total entire lifetime. So that serviceability conditions we need to check and we need to consider. Okay. Or you can say that in simple words that whatever structure that you are going to provide, it must be fit to perform its function satisfactorily during the service life. And that is the requirement. And again, that the condition or the state at which structure or part of structure becomes unfit, that is called as the limit state. Limit state means it is a limiting condition or it is a point at which your structure or the component or the part of your structure becomes unfit. Becomes unfit means काय की तो जो काही कॉम्पोनंट असेल, मटेरियल असेल किंवा स्ट्रक्चरल जो कॉम्पोनंट असेल त्याची स्ट्रेंथ कमी झाली किंवा तो जो काही कॉम्पोनंट आहे तो ज्या लोड कॅरी करण्यासाठी डिझाईन केला असेल तेवढा लोड तो कॅरी करू शकत नसेल तर त्या इन्स्टंटला किंवा त्या सिच्युएशनला आपण म्हणतो लिमिट स्टेट. So it is a limiting condition, limit state. Okay, so these limit states were considered in limit state method. Now, this limit state method details were available in IS 456 under clause number 35. So there is specific section for the structural design by using limit state method in IS 456. You may open page number 67 of your IS 456 copy. It's having with you, and in that clause number 35 gives us information or definition of limit state. Okay, so this is the clause number 35. It says that in the method of design based on limit state concept, the structure shall be designed to withstand safely all loads liable to act on it throughout its lifetime. Okay. So whatever structure that you are going to design, it must withstand safely. It must withstand safely to all loads. All loads. All loads means it is dead load, live load, wind load, earthquake load, or any other miscellaneous loads also. Okay, so all loads you have to consider, and then you have to design that structure so that it will remain stable throughout its intended lifetime. Okay. And it is also satisfies the serviceability requirements. Serviceability requirements already I have told you, such as the limitations of deflection, cracking, etc. These are the two main serviceability conditions. Deflection and cracking. Because deflection will provide the safety to the users, or you can say that the confidence of using that particular building or the structural component. And the cracking gives us the durability or the, you can say that whether the structure is being stable throughout its intended lifetime. 100 वर्षासाठी डिझाईन केला असेल तर 100 वर्ष टिकणार आहे किंवा नाही. For that again there should be limitations regarding in the cracking. जर क्रॅकिंग मध्ये लिमिटेशन्स तुम्ही प्रोव्हाइड केला म्हणजे असं स्ट्रक्चर डिझाईन केलं की ज्यामध्ये क्रॅक्स डेव्हलप होणार नाही तर स्टॅबिलिटी जास्त असणार आहे. And suppose if you are going to apply the loads and those due to the application of load, if minor cracks were started generating on that component, then automatically the deterioration of concrete base starts. Okay, so that point we have to consider, and that acceptable limit for the safety and serviceability requirement before failure occurs, and that acceptable limit is called as the limit state. Okay. So this is the definition of limit state. What is the meaning of limit state? Limit state is the acceptable limit for the safety and serviceability requirements before failure occurs. Which is की फेल्युअर व्हायच्या आधीची जी काही कंडिशन्स असतील त्याला तुम्ही म्हणू शकतो लिमिट स्टेट. म्हणजे व्हॉट इज द मॅक्सिमम लोड, मॅक्सिमम डिफ्लेक्शन, द क्रॅक फॉर्मेशन इज ॲट व्हॉट लोड. सो दोज कंडिशन्स कॅन बी कॉल्ड ॲज द लिमिट स्टेट. म्हणजेच काय तिथपर्यंत तुम्ही त्या स्ट्रक्चरवर लोड अप्लाय करू शकता किंवा तिथपर्यंत त्या स्ट्रक्चरला तुम्ही सेफली वापरू शकता. If conditions exceeds beyond this limit, then failure will occur. Okay. So we have to consider the limits and accordingly we have to design. And that's why the design which is done by using this limit state considerations is called as the limit state design. Okay. So you can go through this clause number 35, and again we are going to discuss about this clause number 35 in detail throughout this course. Okay. These are some points I think which I have already explained, that in the in the method of design based on limit state concept, the structure shall be designed to withstand safely all loads liable to act on it throughout the lifetime. It shall also satisfy the serviceability requirements like limit state of deflection and cracking. The acceptable limit for safety and serviceability before failure is called as a limit state, and the design of structure by this method will ensure us that they will not reach limit states and will not become unfit. Okay, so these are the points about the limit state methods. In next lecture, we will discuss about the types of limits states. Okay, in that we are going to discuss about limit state of collapse, deflection, shear, torsion, bending, etc. Okay, so we'll stop here.
Hello.